Hello everyone, in today's video we're going to be going over some problems about arithmetic sequences. So if you haven't watched the lesson on arithmetic sequences, go ahead and watch that lesson first. I'll put a link in the description. But if you have, then we'll be going over some problems. So I've arranged these problems so that they start from pretty basic stuff and go into more difficult stuff. So the first few problems are going to be fairly simple. All right, question 1. It says determine if the sequence 7, 14, 21, 28 is arithmetic. Explain your reasoning. Well, we know by the definition of arithmetic sequences that if our terms go up or down consistently by the same number, by the same common difference, then that's defined to be an arithmetic sequence. So here, to go from 7 to 14, we go up by 7, from 14 to 21 up by 7, 21 to 28 up by 7. So because all of the terms, the pattern we observe is increasing by 7 each time, we say that this is an arithmetic sequence, and the reasoning is what we just discussed. Okay, so we're going to apply the same logic for all of these problems. So let's see, from 3 to 9, that's plus 6. From 9 to 27, that's plus what? So 1 to get to 10, 17, so that's plus 18. And so on. So we can see that the pattern is changing, or rather the pattern is an arithmetic. In the next video, we'll see that this is actually what we call a geometric sequence. But for now, the point is that the difference changes, right? These numbers, it's going from 6 to 18, so this is not arithmetic. All right, number 3, the common difference. It says find the common difference in this sequence. So let's see, we're going from 20 to 15, so that's minus 5. Again, from 15 to 10, so that's minus 5. 10 to 5, that's minus 5. So our common difference, D, is equal to negative 5. Next problem, identify the first term and the common difference in this sequence. So the first term, or A term, or A1 term, is of course negative 2. And what's the common difference? So that's this one. And what's the common difference? Well, from negative 2 to 4, we have to add 6. From 4 to 10, we have to add 6. From 10 to 16, again, we have to add 6. So our common difference here is 6. All right, let's go on to problem 2. So it says use this formula. This is also on the formula sheet that you can find on our website under the arithmetic, geometric and arithmetic series and sequences section. So using this formula to find the specified terms. Find the 10th term of this sequence. We already talked about how to use this formula and why this formula works. So for this, we're just going to plug in the numbers and figure out the 10th term. So A10, the 10th term, is equal to A1, which is 3, plus, we want the 10th term, so we have 10 minus 1, times, what's the common difference here? We're going up by 3's each time. So times 3. So we get that A10 is equal to 3 plus 9 times 3. A10 is 3 plus 9 times 3, 27. And so we get that A10 is equal to 30. All right, we want the 15th term here. So in the sequence 8, 5 to negative 1, what is the 15th term? So we're going to write that A15 is first term plus 15 minus 1, because we want the 15th term, times the common difference. Here we're going down by 3's. So times negative 3. All right, so here if we solve this, we get 14 times negative 3. And let's see, what is 14 times negative 3? So that should be negative 42. So A15 is 8 plus negative 42. Let me just see, 3, that's 30, 12. Yes, okay. So A15 is equal to negative 42 plus 8. So that's going to be negative 36, 34, negative 34. Perfect. So that's our 15th term. Number 3, calculate the 20th term here. So same drill. A20 is negative 5 plus 20th term minus 1. Common difference, we're going up by 5s here. So times 5. A20 is equal to negative 5 plus 19 times 5. And what is 19 times 5? So I think that should be, that's the same as 20 times 5, 100 minus, so 95. So this is negative 5 plus 95. And so we should get A20 is equal to positive 90. All right, problem 3. It says complete each arithmetic sequence. So we're back to a easy one. How can we complete the sequence to find the missing terms? Well, we can see that the pattern is we're going up by 6 here, right? So for the first one here, we have 18 plus 6 to get the next term, and that should be 24. I'll write the terms here. So 24, and 24 plus 6, that's going to give us 30. So 24 and 30 are the next two terms. What about this one? Well, we're going down by 3's here, so this should be 1, and this should be negative 2. Okay, next one, we're going up by 4's, so the next term here is 13 plus 4, 17, and 17 plus 4, 21. All right, let's have a look at some word problems. Okay, so here it says a technician charges $60 for the first hour and increases the charge by $12 each additional hour. So for the second hour, he's going to be charging $72. What will be the cost after 5 hours of work? So for this one, I should have maybe worded it a little bit differently. Let's go ahead and find the charge of the 5th hour of work, not after 5 hours of work. Okay, so we're going to recognize that this is a arithmetic sequence problem, right? First hour, they're charging 60. Second hour, it's $12 more, so 72. Third hour, it's going to be $12 more again, so 84, and so on. We don't want to do this by hand though, because what if instead of 5 is a small number, we could do this by hand and get the answer, but what if instead of 5 they had 50 here? Then it wouldn't be so easy to do it by hand, right? So we're going to use the formula. So if this is our first term and this is our second and third term, we are essentially trying to find the 5th term here. So A5 is going to be 60 plus, I want the 5th term, so I'm going to put a 5 here, minus 1. And our common difference is 12. We're going up by 12s. So A5 is going to be 60 plus 4 times 12. And this is going to work out to A5 is 60 plus 4 times 12 is 48. And so the final answer will be 60 plus 48, which is 108. So if we need this technician to work for 5 full hours, he's going to charge us $108 for the 5th hour of work. and after that it'll just go up by 12. All right, next problem. Um, it says a warehouse starts with 150 items in stock, decreasing by 15 items each week. How many weeks will it take for the stocks to reach zero? Okay, so here's how we can do this. We start with 150. Again, this is an arithmetic sequence. We have to recognize that the underlying math behind this is an arithmetic sequence. We start from 150, and the week after, so this is, we can think of it as week 1. And after every week, we decrease our stock by 15. So after the first week, when 1 week has passed, we're going to have 135 items in stock. After the next week, 120. Okay, so, and it's going to keep going like this. We want to know how many weeks it's going to take until we reach 0. Well, let's say that the 10th term gives us 0. Just let's pretend this is the correct answer. Well, in that case, I would know that A10 is equal to 0, and I could set A10 equal to our arithmetic sequence formula. So that's this formula. And see for which term number we would get 0. So we don't know if the 10th term is 0, right? So we'll call this n. So I know that an, the nth term, is 0. And so we can say 0 is equal to the first term, 150, plus the number of terms, the term that's going to give us 0, right, our nth term, minus 1 times the common difference. The common difference is negative 15 here, right, because we're going down by 15. So I want to know after, for which term, right, for which term number we're going to get 0. So is this going to be 10? After 10 terms we get 0? Is it going to be 12, 15? So let's solve for n here. So we can start by subtracting 150 from both sides. So if I subtract 150 from both sides, we get n minus 1 times negative 15 on this side. Next, what I'll do is I'll divide both sides by negative 15. So the negative 15s will cancel out here, and we will get, I think I should move this up a little. Let's move it here. Okay, so we're going to get the following. Negative 150 divided by 15 is 10. So we get 10 is equal to n minus 1. And if we add 1 to both sides, right, to get rid of this minus 1, we get n equals to 11. Okay, so we get that the 11th term is 0. Okay, but we have to be careful with word problems. The correct answer here is actually 10. So why is the correct answer 10? It's asking how many weeks will it take for the stock to reach 0. And we know that we start from 150. So it'll take 1 week to go to lose 15, another week to lose another 15, and so on. So our 11th term is 0, but it'll only take 10 weeks for the stock to go down to 0. This is because we'll have to subtract 15 10 times. We start with 150 for the first, is this month or week? For the first week, and go down by 15 for every week after that, right? So our 11th term is 0, but it's only going to take 10 subtractions to get to the 11th term, right? I can show you guys a quick example like this. So let's say we start with 15 and we go down by 5s until we reach 0. So 10, 5, 0. So this is the first term, second term, third term, fourth term, right? But it'll only take, so we subtract 5 here, we subtract 5 here, we subtract 5 here. So even though the fourth term is 0, it only takes 3 weeks or 3 subtractions to get to 0. Okay, so this is something that you guys should remember if you encounter word problems like this. So the correct answer is 10 weeks. Okay, next problem. Sam saves $30 in the first month and increases his savings by $8 each month. How much will he have saved after 12 months? So again, arithmetic series here. First, he's going to have 30, then increase it by 8, so 38, and then 46, and so on. So we want the 12th term here, right? Because, oops, so that's the first term, second term, third term. We want to know by the 12th month or on the 12th month, how much this person is going to have saved up. So we're going to have to calculate 812. 812 is going to be 30, which is our first term, plus 12 minus 1 times the common difference, which is 8, because we go up by 8. So 812 is 30 plus 11 times 8. And so this is 30 plus 88. And we get 812 is equal to, what is that going to be? 118? Yeah. So this person is going to have $118 saved up on the 12th month. Okay, perfect. Let's go to problem 5. Identifying the general term and the number of terms. Okay, so let's see. Determine the general term, an, and the number of terms in each sequence. All right, so it says for the sequence 5, 9, 13, all the way up to 45, find the formula for an and determine how many terms are in the sequence. Okay, so let's first find the general term. The general term expression is an equals to first term plus the term number minus 1 times the common difference. And the common difference here is 4, right? We're going up by 4s every time. So this right here is the general term expression. Okay, next part. It says to figure out how many terms there are. All right, well, how can we figure out how many terms there are in this sequence? Well, I know this is term 1, this is term 2, this is term 3. And if we figure out which term this is, then we would be able to figure out how many terms there are in the sequence, right? Let's say this is the 10th term. If the last term is the 10th term, that means there's 10 numbers in this sequence, right? Or 10 terms in this sequence. So our goal is to figure out which term number 45 is. How can we do that? Well, we can use our formula. We can plug it into our formula. I know that 45 is equal to 5 plus, I don't know which term number it is, so we're going to just leave it as n. And now we're going to have to solve for n here. All right, so how can we solve for n? To start, we can subtract 5 from both sides. So we get 40 as n minus 1 times 4. Then I can divide by 4 on both sides. That's going to give us 10 is equal to n minus 1, right? If we divide by 4 on both sides, this goes away and this becomes a 10. And then add 1 on to both sides, so we get n is equal to 11. That means 45 is the 11th term, and so there are 11 terms total overall. All right, so let's have a look at the next problem. It says for the sequence 30, 25, 20, and 0, write the general term and find the total number of terms. Okay, so yeah, for all of these problems, you guys should be pausing the video and trying them out yourself. But I'm going to assume you've already done that, so we'll just go over it now. So general term again will be an is equal to the first term plus n minus 1 times the common difference. We're going down by 5s here, so common difference is negative 5. So that's going to be the general term expression. All right, now same drill as before to figure out the number of terms. If we figure out the term number for 0, we'll have our number of terms, right? This is term 1, term 2, term 3. We need to figure out which term 0 is. So we'll use this formula. We'll say 0 is equal to 30 plus, I don't know which term it is, so I'll leave it as n. And now we'll have to solve this equation. Subtract 30 from both sides. Divide by negative 5 on both sides. If we divide by negative 5, this goes away, and negative 30 divided by negative 5 is 6. Adding 1 to both sides, we get n is equal to 7. So 0 is the 7th term, and so there are 7 terms total. 7 terms. All right, let's go to problem 6. So more word problems. It says the first term of an arithmetic sequence is 7 and the common difference is 3. Find the 20th term. So this is just an application of using the formula again. So we want the 20th term. So A20 is equal to, the first term is 7 plus 20, because we want the 20th term, minus 1, and the common difference is 3. All right, so we're going to get A20 is equal to 7 plus 19 times 3. So A20 is equal to, so we have 19 times 3, so that is, what, 57? And so A20, did I do this right? 30, yeah, 57. So A20 is equal to 64. All right, there we go. Okay, let's have a look at problem 2. Okay, so problem 2 says the following. It says the 8th term of an arithmetic sequence is 60 and the 18th term is 110. Find the first term and the common difference. Okay, this is a very important problem. You will most likely see variations of this on tests and quizzes. So let's have a look at how to do this. All right, so what is the first term in an arithmetic sequence? Well, the first term is, we usually use the symbol A for it. How do we get the second term? Well, the second term is the first term plus the common difference. What about the third term? The third term is this guy plus another common difference. So it's A plus D, which is A plus 2D. What is the term after that? Well, it's just this guy plus another common difference. So what is A plus 2D plus D? Well, that's A plus 3D. And so on. Okay, so This is the first term, this is the second term, third term, fourth term. We can notice a pattern here. Notice that the third term, all of them have a's, first of all. Now the third term has 2d, the fourth term has 3d, and whichever term we have, we're just going to have one less than that, d's. So we can see that, or we can predict that the eighth term is going to be, and you guys can test this out by writing out the full expression on a sheet of paper, just continuing this. But the eighth term is going to be a plus 7d. And what about the 18th term? Well, the 18th term is going to be a plus 17d. Okay, so the piece of information we need, the two pieces of information we need for this problem are these two. Okay, so we are also told that the eighth term is 60 and the 18th term is 110. All right, so I'm going to erase this guy, or let's see if I can minimize this and just maybe leave it here. Okay, so to solve the rest of this problem, we're going to have to solve a system of equations. Why? Well, I know the eighth term is a plus 7d, and we know that a plus 7d is equal to 60, right? They told us that the eighth term is 60. And the 18th term is a plus 17d, and we know that the 18th term, they told us, is 110. Here we have two equations and two unknowns. A and D are unknowns. Anytime you have some number of unknowns, you need at least as many equations to be able to solve it. So if you have two unknowns, you need at least two equations. If you have three unknowns, you need at least three equations. Okay, let's have a look at how we would solve this. We're going to solve this by the method of substitution. So that's where we take one of these equations and we solve for one of the variables. I'll solve for a. So I'll subtract 7d from both sides and get a is equal to 60 minus 7d. And now that we have an expression for a, we will plug that in for a in the second equation. So in the second equation, instead of a, I'll write 60 minus 7d. And then we have the plus 17d equals to 110. So now you can see that we only have one variable now, d, and we can solve for that. So how can we solve for this? Well, we have 60, negative 70 plus 70, that's plus 10d equals 110. Subtract 60 from both sides, and we get 10d is equal to 50, and divide both sides by 10, we get d is equal to 5. So our common difference is 5. And what is the first term? Well, we can plug in d into this equation, or this equation, or this equation, and solve for a. So I will just plug it into this one, which is just a rearranged form of our original equation, and solve for a. So a will be equal to 60 minus 7 times 5. So a is equal to 60 minus 35. And that means a is equal to, so minus 30, that's 25. Right? So our first term, our a term, is 25. Okay, so 5 and 25 are the answers for that question. Let's have a look at problem number 7. It says, given the first three terms of an arithmetic sequence, find x and determine the value of each term. So we are told that this, and this are three terms and 3 consecutive terms, it should say. So back-to-back terms in an arithmetic sequence. How can we figure out what x is and what the terms are? Well, we're going to use the following idea. And I think I want to, let's color code these. So let's have this be green, this blue color, and pink. Okay, we know that for consecutive terms, right, terms that come back to back, so 1, 2, 3, or let's say we have an arithmetic sequence like this, 2, 4, 6, these are consecutive terms, right, they come back to back. The difference between two consecutive terms in an arithmetic sequence has to be the same. So the difference between 2 and 4 has to be the same as the difference between 6 and 4. So here's an expression that I'm going to write out. I know 5x minus 2 subtracted from 3x plus 1. This has to be equal to, and let's see, what color are we on? Pink. 4x plus 4. Let me fix the 4. Minus 5x minus 2. Okay, so let's briefly go over this again. This term minus this term, that's what we have here. That's a common difference, right? Remember, the definition of the common difference was if you take a term and subtract the previous term from it, you get the common difference. Well, that should be the same if we grab this term, the pink term, and subtract the blue term. We should get the same common difference, which is why I've set the common difference calculated from these two equal to the common difference calculated from these two. So this is the equation we can use to solve for x. All right, so the rest of this is just algebra. So we have 5x minus 2 distributing in the negative. We get negative 3x minus 1 is equal to 4x plus 4 minus, again distributing in the negative, minus 5x plus 2. Let's collect the like terms. So 5x minus 3x, that's 2x, negative 2 and negative 1, that makes negative 3. 4x minus 5x, that's negative x, positive 4 and positive 2 make 6. I'll subtract x from, or sorry, add x to both sides. We get 3x minus 3 is equal to 6. I'll add 3 to both sides. So we get 3x is equal to 9. Divide by 3 on both sides, and we get x is equal to 3. So x is equal to 3, and so let's calculate the actual terms. Let's plug in 3. So if we plug in 3 here, we get 3 times 3 plus 1. 3 times 3 is 9 plus 1 is 10. So that's our first term. That's this, I should do that in green. So 3 times 3 plus 1, that gives us 10. If we plug in 3 here, we get 5 times 3 plus 1, that's 15 plus 1, so 16. And the last one, if we plug in 3 there, 4 times 3 plus 4 equals to 12 plus 4, so is this right? Oh, sorry, this was minus 2. So let me fix that, minus 2. So this is 15 minus 2, which is 13. So, and then this one is 12 plus 4, so 16. And we can see we have a common difference of 3, which is, sorry, not because of that, but we can calculate our common difference to be 3, right? And so we go up by 3 here and 3 here. The difference is the same for both, so we can be sure that this is an arithmetic sequence. Okay, so now that we know how to do this problem, I'm going to go through this next one a little bit more quickly. So we'll have that be green, blue, and pink. I encourage you guys to pause the video and try this yourself before having a look at how I do it. Okay, so assuming you guys have done that now, so let's have a look at how to do this. So same exact technique. Again, using the idea that the common difference between these two has to be the same as the common difference between the next these two terms. All right, let's distribute and solve. So 2x plus 5 minus 4x plus 3 is equal to 6x plus 7 minus 2x minus 5. Okay, so this is going to be negative 2x plus 8 is equal to 4x and then plus 2. Subtracting 4x from both sides, we get negative 6x plus 8 equals to 2. Subtracting 8 from both sides, we get negative 6x is equal to negative 6. Dividing by negative 6 on both sides. This goes away. This turns to 1, so we get x is equal to 1. All right, so yeah, our x value is equal to 1 here. Let's calculate the three terms now. So if x is 1, we get 4 times 1 minus 3, which is equal to 1 for the first term. Second term will be 2 times 1 plus 5, so that's 7. And the last term will be 6 times 1 plus 7, so that's 13. So we're going up by 6 here and going up by 6 there as well, which is good, right? Meaning this is arithmetic and we did everything correctly. All right. So I think that was the end of that. Now we only have the advanced problem sections. So I named this, I put these two problems under the advanced problems. They aren't really much harder. Maybe the first one is a little bit different, but they aren't much harder than the word problems we did above. So let's have a look at them. This first one is interesting. A little bit of a maybe new idea. We're going to look at problems like this more in the next video about arithmetic series. So it says the sum of the first 12 terms of an arithmetic sequence is 144. If the first term is 4, find the common difference and the 12th term. Okay, so here's what we can do for this problem. It says the sum of the first 12 terms is 144. And we're trying to find the common difference and the 12th term. Okay, so we have to think of this in the following way. We know the first term is a, second term is a plus d, again using the same logic we did above. So this is first term, second term, third, fourth, fifth. Third term will be a plus 2d, fourth term will be a plus 3d, fifth term will be a plus 4d, and so on. So if we are to do this problem, we have to calculate the sum of the first 12 terms. Okay, so we have to figure out what a, first term, plus the second term, a plus d, plus the third term, a plus 2d, plus the next term, a plus 3d, plus all the way up to the 12th term, which will be, let me move this over. So the 12th term, we can see the pattern here, right? It should be equal to a plus 11d. right? So, and we know that this sum is equal to 144. Okay, well, we have an a in every term, right? So we have 12 a's total. So I'll just write 12a here. And now we have to sum up the d's. So this is 12a plus. For the d's, we have 1d here, 2, 3, 4, 5, 6, 7, 8, 9, oops, 9, 10, and 11, all the way up to 11d, right? So, I'll just write the d's out front here, right? So, if we have 1d plus 2d plus 3d, right, we can factor out the d from the terms, right? So we can alternatively just write this as d times 1 plus 2 plus 3. That's what I've done here. I've just added all the numbers there and factored out the d. Okay, so let's see. What is this going to come out to? Well, first of all, we know the a, right, first term is 4. So let's plug that in. If we plug that in here, we get 12 times 4 plus, what is 1 plus 2 plus 3 plus 4 all the way up to 11? Well, we can just add this by hand, or we can use a maybe slightly faster method. We're going to notice that 1 plus 11 is 12, 2 plus 10 is also 12, 3 plus 9 is also 12, 4 plus 8 is 12, and 5 plus 7 is also 12. So we have 1, 2, 3, 4, 5 12s. So we have 5 12s, and we have the 6 in the middle as well. So the sum of this is going to be 5 times 12, which is 60 plus 6. So we're just going to have 66d. Okay, altogether we have 66 d's. All right, now we just have a single unknown, d, which we can solve for here. So I'm going to make some room here and solve that equation. So our equation was 144 is equal to 12 times 4 plus 66d. All right, 12 times 4, that's 48, plus 66d. I'll subtract 48 from both sides. So what is that going to give us? 144 minus 48, that's going to be 96. So 96 is equal to 66d. And now I'll divide by 66 on both sides, and so we get 96 over 66 is equal to d. So that's going to be our common difference, and we can simplify 96 over 66. This is going to come out to 16 over 11. So we get 16 over 11 is equal to d. That's our common difference. Okay, and they also want us to calculate the 12th term. So I'm going to erase some stuff here. Let's see. So let's actually erase all of this and just keep d equals to 60 or 16 over 11. So d is equal to 16 over 11. All right, how can we find the 12th term here? Well, we know our arithmetic sequence formula, right? A12 is equal to the first term, which is 4, plus I want the 12th term, so 12 minus 1, times our common difference, which we found to be 16 over 11. All right, so now we get that A12 is equal to 4 plus 11 times 16 over 11. So times 11 divided by 11, those guys cancel out. We get 812 is equal to 4 plus 16. And so A12 is equal to 20. All right, and that brings us to the last problem of the day. This one is a little bit simpler. It says the fifth term of an arithmetic sequence is 22 and the 10th term is 37. Find the first term and the common difference. We've already done a problem similar to this, so it should be familiar. So again, first term is A, second term is A plus D, third term is A plus 2D, and so on. This is the first term, second term, third term. So the fifth term and the 10th term we can predict. The fifth term is going to be A plus 4D, and the 10th term will be A plus 9D. And they tell us that the fifth term is 22 and the 10th term is 37. Okay, so that means we can write two equations. A plus 4D is equal to 22, and A plus 9D is equal to 37. So we're just going to solve these two equations, again by method of substitution, and that's going to give us our common difference and first term. I'll solve for A here. So A is equal to 22 minus 4D, and we'll plug that into the second equation. So 22 minus 4D for A, and so it's, instead of writing A, we write this down, and then we have our plus 9D, should be in green, plus 9D is equal to 37. Okay, so we have 22, negative 4D plus 9D, that's 5D, is equal to 37. We subtract 22 on both sides, so we get 5D is equal to 15. And now we simply have to divide both sides by 5 to get that D is equal to 3. So our common difference is 3. How can we find our first term, A, which they also asked for? Well, we can simply plug this back into this equation, or this equation, or this equation. All of them will give us the same answer. So I'll plug it into this guy. So we have that A is equal to 22 minus 4 times common difference, which is 3. So we get A is equal to 22 minus 12, which gives us A equals to 10. Okay, so that was the last problem. I hope you guys found this helpful. If you have any questions, feel free to leave it in the comment section, and I will do my best to answer them. All right, see you guys in the next video. Bye for now.